Hello, Professor. This is Manish, and hello, class. So this is my video recording for the our final exam submission, basically. Gonna try. Oh, wait, just give me a second. Yeah, one person. That's just me. So I'm gonna try and share my screen. There you go. I think it's a yeah. You are sharing. It says I'm sharing my screen. So. Before I even start on explaining things, I do wanna let you know I have the notebook. It's the same thing from what I'm looking at the screen that I might use to, keep a tally of. And I'll go by question one and question two. And I also have another screen here connected to my computer, and that just has questions and my submission basically. So I might take a look every now and then to what the question is asking. So yeah, let's go. So the mission one, secure the barricades, right? So what I did was, first of all, we had to find the we had the insert keys given to us, and we had to find the what do you call hash table using the kmod data, and our insert keys were 10, 22, 31, 4, 15, 28, and 17. So essentially, all we did was hash table use the hash table using kmod 7, and for uh, 10, which is one of the insert keys, our 10 mod 7 is 3, so position would be 3. For 22, 22 mod 7 is going to be 1, so 1. 31 mod 7 is going to be 3, so we check 4, and then since it is open, it goes to 4, and so on and so forth. And we did this for every single one of them, all the keys that we have, that is 10, 22, 31, 4, 15, 28, and 7. And after inserting all the items, we wrote what do we call it? What did we do? We wrote the index, and we wrote the value that we generated from here, and that is all. That's all we did, and we could find the what find the thing using hash table. And for the alternate, uh, this was kind of a weird one. Alternate methods, other methods that we could use. So on the questions here, actually, just give me a second. This is way too hard. Uh, I'm just gonna keep one screen so that it's easier for me. Yeah, there you go. Sorry about that. So for the alternate methods, where it is. On the hint, it has said that zombies hate chaining and they trip over linked list, but I kind of did not see that at first either. So I just went with chaining, quadratic probing, and double hashing. But then I saw that, and I also wrote one more for rehashing. But I'll go over each one of these really quickly, and then we could go on from there. So chaining is basically hash table slot sorted in a linked list manner, and all the keys that hash to the same index are placed in that list. So basically, every insert keys that we have that is hashing to the same index, we insert that. That's pretty simple. Quadratic probing is again very, very simple. On a collision, all we do is use the quadratic expression or quadratic patterns and insert on each one of those indexes that we get from our quadratic index. I mean, quadratic probing. And double hashing is we use a second hash function, and on a collision, the next available slot is determined by the second hash function. And the rehashing is also pretty much the same. The only difference is when the table gets full, we create a bigger table and hash everything again. That's the only thing. So that was mission one, securing the barricade. So for mission two, build escape routes, we had to use MST Crucial, and this was for 10 points. And give me a second, where is the question? So for our task here, um, where is it? Your task. We have been asked find the minimum spanning tree to escape, and so all routes selected in order, and compute total danger level, which is basically time to escape. So all we did was we listed all routes and their danger levels, and then sorted the rows from least dangerous to most dangerous, basically. And that would be, these are just the danger levels. We have to sort edges by weight in an ascending manner, so that would be this, right? And once we do that, each road is then sorted and added into the spanning tree, right? So, and this is for the route selected in order. So all we did was what did we do actually? Just give me a second. So we have to process age in sorted data and adding if they don't create a cycle. Yeah. So for each of these ascending map and data that we have from QTA, which would be quarantine zone, armor shelter, and all of that, this is the short version of that. We process A, so which connects G to, so for let's say Q to A1, our components are all these Q, A, G, S, and S. Again, we take G to Q, and our which connects to G through G, Q, A, S, and S, and we do this for again and again and again until we get to our last. And the reason we stop after four edges is because spanning tree for five vertices need exactly four edges. And the total danger that we have, which would be the sum of all the ages that we got, is gonna be 13, I think, if I'm not wrong. Yeah, 1, 2 plus 2 plus 4 plus 6 is 13. And the way we got that is basically this. Everything that we did, we basically sorted out based off of Kruskal algorithm and coming from ascending order. So that's pretty much it for this one. And we got our data to be 13, right? And where is it now? Our mission three is, where is mission three? Craft weapons rod cutting. Okay, so we have our rod length to be 8, and all the prices are given here. And the question is, fill the DP length for max revenue, which would be the strongest arsenal, and each correct DP entry is equal to one less zombie chewing on your leg. So all we did was we beat the here. It's pretty simple. So we had P11, P25, P38, P49, P510, P617, 1720, and all these are given here. 1 is to 1, 2 is to 5, 3 is to 8, 4 is to 9, 5 is to 10, 6, 7. All of these are given. So all we did was we build a DP table. R would be our function, and X would be the denoting value. So R is to X, for X would be 0 to 8, where each entry is best revenue for a rod length of X, right? And then the table shows increasing revenue up to R8, which would be 22, I think. It's somewhere in here. Yeah, which would be 22 right here. R8, which would be 22. And basically for R1, we add 1 plus R0 gets us 1. For R2, 1 plus R1, 5 plus R0, which gives us 1 plus 1 is to 5 is equal to 5. So R2 stays at 5. And we do the same for all of the prizes we have, 1, 2, 3, right? All these prizes that we have, and that is all. And for mission 4, which would be decode zombie signals. Oh, this one was kind of hard, at least for me. So where is? Let me show you. So decode zombie signal. So we have zombie attack, and on the question it says safe zone your first name, but I think the question was asking me to put our first name, so I just put safe zone Manish. I don't know if that's even right or wrong, but that's what I did. And we it has asked to build the DP table for the longest common subsequence, basically LCS of these two signals. Basically, all we're trying to figure out is what is the LCS value when we combine these two signals. That is all. And zombie attack has 13 characters, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. For zombie safe zone monies, it is going to be 14. So we have safe zone monies right here and zombie attack right here. And the first one is all zero because I wanted to make 14 characters so that it is easier to compare, right? And for each cell in the table, what we did was we compare the character from both the signal, the first to first, the second to second, and so on and so forth. And after we completed the table, look at we found that the our LCS result of longest common subsequent is Zoma length 4. That's all we did in this. This one is pretty simple. Now, mission five, pack supplies. This one is actually fractional knapsack, and all this question is asking us to do is we have item based on value and weight, and then our maximum capacity of our backpack is 100. So compute it is asking us to compute max value using fractional knapsack basically. So the first given information we have is our item on value and weight is 60, 10, 120, 120, 30, 80, 40, 150, 50, and 260. Yeah, that's correct. And capacity 100. I mean 100, right? So all I did was to maximize the survival value, right? We get the weight, I mean, value to weight ratio for item one to item six. And since item one is 60 to 10, we divide 60 by 10 to get six. And 100, item two is 100 to 20, so we get five, and so on and so forth. And once we got that, we basically add item one from we start at the highest ratio and we add the items to until we it was full basically, and the full would be 100. So for item one, we total value is right, remaining capacity is 90 because weight is only 10 and we got the value 60. For item two, weight is 20, value is 100, so capacity is now at 30 full, so we have 70 left, and value is going to be 160, 100 plus 60. And for item three, our weight is 30, value is 120. So since we had 30 earlier, we are 30. So we are 60 full and our capacity is 40 and total value is 280. And item four, the weight is 60, but we only have 40 available. So we cannot add all 200 value in it. We can only add 40 of it out of the 60 that it has, which comes down to 133.33. And we add all of those. So our max survival value is 413.33. This one is pretty simple. Fractional knapsack, like we did in class, and the like we studied. Yeah, very simple. And the last question is where is it? Navigate the dead zone Bellman Ford, right? And what essentially what we're given is that the city is crawling with zombies and we need to find the safest path to safe zone, right? And our survivor location are AH, which would be abandoned hospital, police barricade, PV, zombie mall, JM, Born School, BS, and safe zone SZ. And road with danger level, these are just ages level that we have been given. AS to PB is 7, AS to JM is 7, PB to JM is 8. All of these are already given in question, but I don't know why I'm even explaining. So basically what it is, the question is asking us to do is it has given us a starting energy level, which would be total value from mission 5 divided by 10, right? Instead of 0. And we're using this as the initial distance from AH, which would be our starting point, right? So that's what we're doing right here. Our starting energy level is 41.33, and everything else I've written out infinity because I don't know. I don't think zero would be the right answer. I don't know. Maybe I'm wrong, to be honest. And for the Bellman for iterations, right? Uh, so our task says so distances updates after each iteration. So I think we did iteration up to 3 or 4 or something. So we started by initializing distance with the energy level and everything else. And once the second step would be to relax all the edges on one iteration, updating distance from whenever a sorter or danger path was found. So this one was iteration one, AS to PV, right? 41.33 and PV is going to be 6. So 47.33, PV stays at 47.33. And for JM, it's going to be plus 7. So that's going to be 48.33. And we compute all of these basically what it has asked us to do. And the important thing here is on ZM, which would be zombie mall, right? 47.33, we get plus 8, we get 55.33. But here JM states at 48.33. Some have negative values, so we subtract it, we update it basically. And this is iteration 1, AH 41.33, PV 43.33, 48.33, and SJ 43.33. Okay, and we do the same thing again for iteration 2 and then update it. Same thing for again iteration 3 and then update it. It is essentially what we're trying to find is the shortest safe zone distance. And once we are doing from go from iteration 1 to iteration 2 to iteration 3, that comes out to 39.33 SZ. So that is our going to be answer. And I think there is one other question for 4 points which says explain how Bellman-Ford detects a negative cycle. And for the detection of negative cycle, Bellman-Ford by performing one extra iteration after the one iteration, if any edge can still be relaxed, which basically means distances decreases in our case, then it would mean that the negative cycle exists. And I've given example from whatever we did earlier up here. We checked, and then after we are done, from PB to SJ to BS to PB would be checked, and then after we are done checking, if we find that repeated relaxation occurs, it would mean the looping is continuing indefinite, non-stop, indefinitely. I don't know how to say that word, which basically mean negative cycle must be avoided, and that's what it's in the question. So this is everything that I have done. I don't know. I might be wrong in some of these, but that is all. Thank you.